So let us continue our lecture today. So any questions on the midterm? So on the midterm, I put all of the solution online, so you can check. But basically, the midterm follow exactly like what we have in the practice test. All right. So let us continue case number 4. So as we discussed in the previous class, we have ax second plus bx prime plus cx is equal to an empty. Right? So this is a homogeneous second order, inhomogeneous second order differential equation with constant coefficient. We can now what we have is case number 4. In this case, the force will be of the form E1 sinus of cosinus beta t plus E2 sinus of beta t, right? This is the form of the force. In this case, the force is of sinus and cosinus form, and so the particular solution will be xp is t to the k a times cosinus beta t plus b times sinus of beta t. So k is the multiplicity of beta I as the root of the characteristic equation. All right, so the characteristic equation will be AR squared plus BR plus CZ. So I explain again. In this case, the force is of sinus and cosinus. So what you do is you have to choose the same particular, the same form of the particular solution, right? So you're gonna have cosinus beta t, and sinus beta t, sinus beta t. So it's exactly the same, except that you have to take into account the multiplicity k. So what is k in this case? K is the multiplicity of beta I. So remember that here this is an imaginary number. So you have to check if beta I is a solution of the characteristic equation and what is the multiplicity of this number. All right. So let us consider example 2.6.8. All right. So in this example, we have x second plus 2x prime plus 2x is equal to 3 to the power minus t plus 4 cosinus of t. All right. Right? So in this case, you don't have exactly what you have here, like the cosinus function. You have a mix between exponential and cosinus. So what should you do? Yes?
Will the particular solution have two terms where one term is the particular solution of what would have just been if the function was just 3 times e to the negative t, and then the second term will be the particular solution if the function was just 4 times cosine?
Excellent. Can you stand back up, please? So basically, in this case, what you do is that you have to find a particular solution which has two terms, right? The first one will be the solution of the one with the exponential, and the other one will be with the cosinus. All right. So the particular solution xp will be xp is xp1 plus xp2, where xp1 so you have xp1 second plus 2xp1 prime plus 2xp 1 is equal to 3x power minus t, and xp2, so you have xp2 second plus 2xp2 prime plus 2xp squared is 4 cosinus of t. All right? So the particular solution will be the sum of two terms. The first one is the particular solution of 3e to the power minus t, and the second one will be the particular solution of the equation in which the force is 2 cosinus, 4 cosinus t. Questions? Right, so let us try to find a particular solution for the first one. All right? So find x1p. So how do I find x1p? Yes?
It'll be t to the k times a constant a times e to the negative t.
Right. Well, what is the k in this case?
And k is the multiplicity of -1 as a root.
Right. Can you say the micro paper, please? So xp1 will be t to the k, k1, a times e to the power minus t. All right. So this is case number 1. This is case number 1. So xp1 will have the form a times t to the k1 e to the power minus t. So what is the value of k1? So k1 will be the multiplicity of k1 is multiplicity of -1 as the root of the characteristic equation, which is r squared plus 2r plus 2 is equal to 0. All right? So k1 will be the multiplicity of -1 as the root of r squared plus 2r plus 2 is 0. All right? So but -1 is not a solution. Right? So you have -1 square plus 2 times -1 plus 2 is different from 0. So k1 is 0. It's clear? Questions? It's good. Right? So then this means that xp1 will be a times e to the power minus t. All right? I explain again. In this case, you have a force which is the sum of 3e to the power minus t and 4 cosinus t. All right? What you do is you find a particular solution which is the sum of two particular solutions of two inhomogeneous equations. One is with 3e to the power minus t, and the other one is with 4 cosinus t. All right? Questions? Right. So in this case, you want to find xp1. When you find xp1, according to case 1, it has to have the form a t k1 e to the power minus t, right? And k1 is the multiplicity of -1 as a root of the equation. But -1 is not a root of the equation, so k1 is 0. Now I have to find a. How do I find a? Yes?
You plug in what we got for xp1 into that, like, into the equation xp1, yeah.
Can you stand the back of the paper, please? So in order to find a, you're gonna plug it here, all right? So you're gonna have xp1 second will be a e to the power minus t, and xp1 prime is minus a e to the power minus t. All right? So you plug it over there, you're going to have a e to the power minus t, which is xp1 second, and plus 2 times of minus a e to the power minus t. This is xp1 prime plus 2 times a e to the power minus t, and this is 3e to the power minus t. All right? Questions? All right, so you're going to take this particular form and you plug into the equation. With a e to the power minus t, xp1 second will be a e to the power minus t, xp1 prime will be minus a e to the power minus t. All right, so a e to the power minus t is the xp1 second, xp1 prime will be 2 times a minus a e to the power minus t, and this is 2 times xp1. So what is the value of a? Yes?
3.
Can you sign the back of the paper, please? So you plug this to the equation, and you get a e to the power minus t is equal to 3 times a e to the power minus t, so a is equal to 3. All right? Now I have to find xp2. All right, now I have to find xp2, right? So xp2 will solve the equation where you have the cosinus. This will be 2 times xp2 second, 2 times xp2, and this is equal to 4 times cosinus of t. All right? So, what is the form of xp2? Yes?
It's t to the k times a times cosine t plus b times sine t.
Yes, can you sign the back of the paper, please? So in this case, you're going to have t to the k times a cosinus of t plus b sinus of t. All right? Remember that here you don't have sinus, but in the particular solution, you have to put sinus. All right? Because the form that we have is e1 cosinus plus b, e2 sinus, and in that case, e2 is 0. All right? Questions? Right, so what is the k in this case? Yes? The multiplicity, yeah, can you sign at the back of the paper, please? The multiplicity of I as a solution, a root of r squared plus 2r plus 2. And so what is this multiplicity? Right, so you look into the 1 here, right? And you multiply with I. So k will be the multiplicity of I as the root of this equation. And what is this multiplicity? What is the value of k?
0.
0, yes. Can you say the back of the paper, please? So when you plug I here, right? So you have I squared plus 2I plus 2. So this gives me minus 1 plus 2I plus 2. And this is 1 plus 2I, and this is completely different from 0. All right? And so k has to be 0. Good. I explain again. To find xp2, what you do is that you consider particular solution of the form t to the k, a cosinus t plus b sinus t. All right. So here you don't see sinus in the form of the force, but here you still have to put sinus. All right, because the general form of the force will be e1 cosinus t plus e2 sinus t. So e1 in this case is 1 and e2 is 0. You still have to put sinus there. So xp2 will be t to the k, a times cosinus t plus b times sinus t. All right? K is the multiplicity of I as the root of the characteristic equation. So the characteristic equation is r squared plus 2r plus 2. I put I back here, which gives me k is 0. Questions? Now, yes, so xp2 now will be a times cosinus of t plus b times sinus of t. All right? So how do I find a and b? Yes?
You find what xp2 minus xp whole time is and put it in the middle.
Yes, can you sign the back of the paper, please? So I'm gonna find the derivative of this and I plug everything into the equation. Right, so xp2 prime, what's the value of xp2 prime? So, yes?
It will be, so the first derivative is negative a sine t plus b cosine t.
Right. Can you sign the back of the paper, please? All right, so the first derivative will be that, and the second, what is the value of the second? Yes?
It would be negative a cosine t minus b sine t.
Yes, can you sign the back of the paper, please? All right, so derivative of cosinus is minus sinus, and derivative of sinus is cosinus. All right? Right, so now I have everything. I'm going to put them back into the equation. I have a minus cosinus t minus b sinus of t plus 2 times of minus a sinus of t plus b cosinus of t plus 2 times a cosinus of t plus b times sinus of t, and this is 4 times cosinus of t. So this is xp2, this is xp2 prime, and this is xp2 second, right? After I compute everything, I plug everything back into the equation. So xp2 second will be minus a cosinus t minus b sinus t. xp2 prime will be minus a sinus t plus b cosinus t. xp2 will be a cosinus t plus b sinus t, right? How do I find a and b? Yes?
Would you group all of the like cosine t's equals the 4 cosine t and all the sines equals?
Yes, can you sign the back of the paper, please? So in order to find b, so we use the similar method with the previous exercises. So the name of this method is identifying coefficient. Identifying the coefficient. All right. So in order to find a and b, you identify the coefficient, right? So you're gonna group all of the a and all of the b. So here you have sinus, here you have sinus, and here you have sinus. So I have minus b plus minus 2a plus 2b sinus of t. All right? I'm gonna group all of the coefficient of sinus, minus b minus 2a plus 2b. All right? And now I'm gonna group all of the coefficient of cosinus. So this is cosinus, this is cosinus, plus minus a plus 2b plus 2a cosinus of t, and this is equal to 4 times cosinus of t. Right? So the first one gives me b minus 2a sinus t. The second one gives me a plus 2b cosinus t, and this is equal to 4 times cosinus t. Right? I explain again. So in order to find the a and b, you use a method that we usually use, and the name of this method is identifying the coefficient. You're gonna group all of the sinus, and you're gonna group all of the sinus, So here I have minus b, minus 2a, plus 2b. This is the coefficient of sinus. I group minus a plus 2b plus 2a. This is the coefficient of cosinus. And everything is equal to 4 cosinus t. All right? So in this case, how do I... so now I have a system, right? So what is this system? Yes?
Like you'll set b minus 2a equal to 0 and a plus 2b equal to 4,
Yes.
and then solve.
Yes. Can you sign the back of the paper, please? So you're gonna identify the coefficient, right? You have a plus 2b is equal to 4, and b minus 2a is going to be 0. So this is going to be 0, right? So I identify the coefficient of cosinus t and cosinus t. So this is going to be 4, and the other terms has to be 0 because on the right hand side you don't have sinus. So this is a system that I have. So how do I solve this system? Yes?
You can set b equal to 2a and then plug in 2a.
Yes. Can you sign the back of the paper, please? So basically, b minus 2a is 0, which means that b is equal to 2a, which means that a plus 2b is a plus 4a, and this is 5a, and this is equal to 4. So a will be 4 over 5, and b will be 8 over 5. All right? Now, you have a plus 2b is 4, b minus 2a is 0. b minus 2a is 0 means that b is 2a. All right? So I'm going to plug 2a into the first equation. A plus 2b will be a plus 4a, and this is 5a. But for the first equation gives you 4, so a is 4 over 5, and b is 8 over 5. Questions? So now, what is the formula XP2? Yes?
4 over 5 cosine t plus 8 over 5 sine t.
Yes. Can you sign the back of the paper, please? So 4 over 5 cosinus t and 5 over 8 over 5 sinus t. Questions? Now, what is the general? What is the form of the particular solution for the original equation? Yes.
It's 3 times e to the negative t plus xp2, so 5 cosine t is 5 sine t.
Yes. Can you sign the back of the paper, please? So now you're gonna have 3 times e to the power minus t plus 4 over 5 cosinus t plus a over 5 sinus t. All right. Now let us go back to the original method. So suppose that you have xp1 second plus 2xp1 prime plus 2xp1, and this is 3 times e to the power minus t, and then xp2 second plus 2xp2 prime plus 2xp2 is 4 cosinus of t. So y xp is xp1 plus xp2. Right, so from the original equation, I mentioned that, okay, what you do is you find the particular solution for the first equation and the particular solution for the second equation, and you take a sum. Why can you do that? Yes?
Is it because a linear combination of solutions is also a solution to the
Right.
differential equation?
Right. Can you sign the back of the paper, please? Because of the linear combination, right? So this is because of this. So you have xp prime will be xp1 prime plus xp2 prime, right? Because this is a linear combination, you can differentiate, right? So xp is xp1 plus xp2, which means that xp prime will be xp1 prime plus xp2 prime. And so you have xp second is xp1 second plus xp2 second. Right, so now you want to have what? You have xp second plus 2 xp prime plus 2 xp will be what? Will be xp 1 second plus xp2 second plus 2 xp1 prime plus 2 xp2 prime plus 2 xp1 plus 2 xp2. All right? You know that, so now if I consider xp to be the sum of xp1 and xp2, right? xp prime will also the sum of xp1 prime and xp2 prime, and xp second will also be the sum of xp1 second and xp2 second. All right? Now you consider the equation. xp second plus 2 xp prime plus 2 xp. This is the xp second. This is the xp1 prime plus x2 prime. This is the xp, right? Now I'm gonna group this, and I'm gonna group this. What do I get? Right, so I consider xp to be xp1 plus xp2. I take all of the derivative, and I group all of the xp1 and xp2. What do I get? Yes?
The left group would be equal to 3e to the minus t, and the right group would be equal to the 4 cosine t.
Yes, can you say at the back of the paper, please? So the first one gives you 3 into power minus t, and the second one gives you 4 times cosinus. All right? This is why you take a sum. This is because then you have xp second plus 2 xp prime is equal to this guy. All right? This property is a linear combination. This is because the equation is linear, right? Because the equation is linear, you can take the linear combination of two different roots, and when you combine them, you can combine the two forms as well. Questions? All right. So now let us. So this is the particular solution. What is the next step? Yes.
Plug in xp1 and xp2. So you have.
Now we have that particular solution. In order to have the general solution, how you do it?
Like you would find the roots of the original, like the characteristic equation, and then you could use that to write like the first part of the general. That's like the C1 plus C2.
Right. Yes, at the back of the paper, please. So after having the particular solution, you solve the homogeneous equation, right? This is the particular solution. So now let us solve the homogeneous equation. So homogeneous equation. You have x plus 2x prime plus 2x is 0, all right? All right, so this is the homogeneous equation. In order to solve this homogeneous equation, you have to write out the characteristic equation. Plus 2. And I want to find the two roots. What are them? What are they? What are the two roots of this homogeneous equation? Yes?
R is equal to -1 minus I, and R is equal to -1 plus I.
Excellent. Can you sign the Minecraft paper, please? So in this case, you're going to have delta is 2 square minus 2 times 4, and this is minus 4. So then this is going to give you plus or minus square root of 4 divided by 2 and this is 2 plus or minus 2i divided by 2, and this is 1 plus or minus I. All right? So I explain again. After you have the particular solution, what you do now is you solve the homogeneous equation. The homogeneous equation is x second plus 2x prime plus 2x is 0. The characteristic equation is r squared plus 2r plus 2 is 0. The delta in this case is minus 4. So you have these two, R1 and R2. All right? Good. So what are the two solutions? Yes?
Should it be -2 plus or minus 2i over 2? So it'd be
Negative 2, what?
R1, 2 is in the formula negative b plus or minus the square root, so the formula should say negative 2 plus or minus the square root of 4.
Yes, square root 4 is 2.
Right, but there's
like
two
the first two.
from the equation, so
Should that be negative?
I don't so, what?
Because it's negative b plus or minus the square root of delta over 2, right? So shouldn't the 2 before the plus or minus be negative?
This is plus or minus, right? So this is,
No, the 2 before that one.
yes, yes. Can you three both all side of the back and the back of the paper, please? All right, excellent. Okay, you three all side. So now, what are the two solutions of this equation? Yes.
E to the negative t times cosine t, and then the other one is e to the negative t times sine t.
Yes. Can you stand the back of the paper, please? So x1 will be e to the power minus t cosinus t. X2 will be e to the power minus t sinus t. All right? So what you do is that you put this minus here and this one to the cosinus. All right? Questions? So the general solution will be so what is the general solution? Yes?
3e to the negative t plus 4 over 5 cosine t plus 8 over 5 sine t plus c1 e to the negative t cosine t plus c2 e to the negative t sine t.
Yes, can you stand the back of the paper, please? So now you're gonna have 3e to the power minus t plus 4 over 5 cosinus t plus 8 over 5 sinus t plus c1 e to the minus t cosine sinus t plus c2 e to the power minus t cosinus t. All right? Questions? It's clear. Right, so you know how to solve this kind of equation. Well, the case number 1 is hard. So any questions on case number 4? It's good. So case number 1, case number 5. Case number 5. So ft will be dt cosinus of beta t plus qt sinus of beta t. So p is of order m, q is of order n, and s is the max of n and m. All right? So in this case, this is even another example. All right, so so I'm gonna have f, which is the sum of a polynomial times cosinus and a polynomial times sinus. All right. The first polynomial is of order m, and the second one is of order n. And I'm gonna take s to be the max of m and n, right? So the xp will be t to the k of a0 plus a1t plus ats cosinus of beta t plus b0 plus b1t plus bs ts sinus of beta t. K will be the multiplicity of beta I as the root of the characteristic equation. All right. The force will be P times cosinus beta t plus Q times sinus beta t. P is of order n and Q is of order n. This S will be the max of m and n. All right. And so what you do is that you multiply a polynomial with cosinus, and you multiply a polynomial with sinus. All right. The K here will be again the multiplicity of beta I as a root of the characteristic equation. All right. Example. So from case 5, from case 1 to case 4, if I ask you to solve that in exam, you have to do everything that I show you. All right. But if from case 5 to case 9, I'm gonna ask you just to write out the form of the particular solution. I don't ask you to compute the coefficient. So example 2.6.10. So you're going to have x second plus 4x term plus 4x is equal to t squared cosinus of 2t plus 1 minus c sinus of 2t. All right. This is the force that we have. We have t squared cosinus of t, 2t, plus 1 minus c sinus of 2t. All right? What is the S in this case? Yes?
S is 2.
Right, S is 2. Right. So because here this is pt, and this is qt. All right? So you look into the, can you sign the back paper, please? So you look into the two coefficients of sinus and cosinus. This gives you one polynomial, and the other one gives you also another polynomial. All right. So so pt is of order 2. So m is equal to 2, and qt is of order 2 as well, and it's also equal to is of order 1. And it's 1. So you're gonna take the max of 2 and 1, and this gives you 2. All right? Questions? So I explain again. In this case, you have a force of this form. All right? You look into the two coefficients of cosinus and sinus. You have two polynomials. The first one is of order 2, and the second one is of order 1. You're gonna take the max of the two order, which is 2, and this is the S that you have. What is the form of XP in this case? Yes?
It's going to be t to the k, where k is the multiplicity of 2i as the root of the characteristic equation, and then that times a naught plus a1t plus a2t squared times cosine of 2t plus b naught plus b1t times the sine of 2t.
Yes, can you sign the back of the paper, please?
Has the paper.
Yes? So you're gonna have xp is t to the k a0 plus a1t plus a2 t square cosinus of 2t plus b0 plus b1t plus b2 t square sinus of 2t. All right, so k, all right. In this case, s is 2. What I do is that, okay, I put a0, a1, t, a2, t squared. This is the coefficient of cosinus 2t, and then b0 plus b1t plus b2t squared. This is the coefficient of sinus 2t. All right? K is the multiplicity. The multiplicity of 2i as the root of r squared plus 2 plus 4 is equal to 0. All right? In this case, the t to power k, you have to put t to power k, and k will be the multiplicity of beta I as the root of the characteristic equation. So what is the multiplicity in this case? Yes?
Just one.
Yes, can you slide back the paper, please? So the multiplicity is 1, right? Because r squared plus 4 is 0, has 2 roots. 2i and minus 2i. So the multiplicity of 2i is 1, right? So then you have xp is t times a0 plus a1t plus a2 t squared cosinus of 2t plus b0 plus b1t plus b2 t squared sinus of 2t. All right? Questions? So for this kind of problem, you don't have to find all of the coefficients. This is a lot. But what I'm gonna ask you in the exam is that you have to write out the general form of the particular solution like this. All right, and that's it. Questions? It's clear. Right. So if there's no questions, we go to case number 6. Any questions on case 5? Case number 6. Case number 6, ft will be e1 e to alpha t cosinus of beta t plus e2 e to alpha t sinus of beta t. So in this case, xp will be t to a k. A e to the alpha t. Cosinus of beta t plus b e to alpha t sinus of beta t. And k is the multiplicity of alpha plus beta I as the root of the characteristic equation. Characteristic equation. All right. Questions? So ft will be e1 e to the alpha t cosinus beta t plus e2 e to the alpha t sinus beta t. So sp will be t to the k. So k is again the multiplicity of this alpha plus I times this beta. And that's it. Questions? Now let's try to do one example, and you would understand. Right. So example 2.6.12. You have x second plus 2x prime plus 2 is equal to 5 e to the power minus c cosinus of t. All right. So in this case, you have to solve x second plus 2x prime plus 2 is 5 times e to the power minus c cosinus of t. Right? What is the form of this xp? Yes?
T to the k times a times t to the, a times e to the negative t times cosine t plus b times e to the negative t times sine t, and k is the multiplicity of negative 1 plus I.
Yes, can you sign the back of the paper, please? So xp will be t to the k, right? You just replace alpha. So in this case, alpha is 1, right? So this is alpha. And in this case, beta is 1. So here you have a e to the minus 1. And then cosinus of t plus b times e to the power minus t sinus of t. All right? It's clear? You have x second plus 2x prime is 5 times e to the power minus t cosinus of t. In this case, the alpha is minus 1, beta is 1. So the xp will be t to the k e to the power minus t cosinus t plus b times e to the power minus t sinus t. Right? So the k will be the multiplicity of minus 1 plus I as the root of I squared plus 2r plus 2 is equal to 0. So what is this multiplicity?
0.
No. Yes?
1,
1. Why?
because the root of that is minus 1 plus or minus I,
Yes.
so it'd be 1.
Yes, can you sign the back of the paper, please? So this is the equation that we solved already, right? So r squared plus 2r plus 2 has two solutions, has two roots. Minus I plus I and minus I minus I. Right? So this is the guy that we want, right? So k will be 1. So xp will be t times I e to the power minus c cosinus t plus b times e to the power minus c sinus of t. All right. Questions? Right. I explain again. In this case, you have x second plus 2x prime is 5 times e to the power minus t cosinus t. All right. xp will be t to the k a t to the power minus t cosinus t plus b times e to the power minus t sinus t. So k is the multiplicity of minus 1 plus I as the root of r squared plus 2r plus 2 is 0. All right. But this equation has two roots, minus 1 plus I and minus 1 minus I, because this is something that we solved in a previous example. So k is 1, and you replace 1 here. Questions? So again, for this kind of problem, I don't ask you to find A and B coefficients. Yes. So let us consider a more complicated example. Example 2.6.30. You have x second plus 2x prime plus 2 is e to the power minus c cosinus of 2t plus e to the power minus t sinus of 2t plus e to the power minus t minus 3 cosinus t. All right. So this is a very horrible form of the force, right? How can I do it? Yes?
Was you first going to factor out the e to the negative t? Or add the cosine?
The first one is e to the power minus t. Yes, can you sign the back of the paper, please? Right, so the first one is e to the power minus t and yes. Yes? Yes? Okay, yes.
Would the form of the particular solution be, so you'd have t to the k times a times cosine 2t plus b times sine of 2t, and then you'd have a second term for that last one. You'd have another one, you'd have t to the k, oh excuse me, I forgot an e to the negative t. Remember, for instance, you multiply that for sine by e to the negative t, and then it'd be plus e to the negative t times third constant, c, times, I'm going to start over, sorry. You could factor out the e to the negative t out of the entire thing, and you could have t to the k times the entire thing, and then you could have a naught times cosine of 2t.
But how can I do with the cosinus? If you factor out the e to the power minus t. Right, so there's still the cosinus, right? Any better ideas? Yes? Yes?
Just split up the stuff on the bottom so that negative 3 cosine t, because it has a different coefficient inside the cosine than the top two. So you would have to split those up into two different, like xp1 and xp2.
A very good idea, but it's not a good splitting. But can you sign the back of the paper, please? Right, so you're gonna do like in xp1 and xp2, but here it's not just that. So what is the complete splitting for this? Right, so you're gonna split like in xp1 and xp2 in the previous example, but in this case, it's more complicated. And how should we split the force? Yes?
The first term will be case number 6, that's e to the minus t.
This
times
case
cosine
number 6,
t,
right?
Yes. And then on the second one, we have case number 2, which is e to the minus t.
Case 2, right?
And then we have case number 4.
Right. Right. Inside the back of the paper, please. Right? So what you do is exactly like what we did for xp1 and xp2. You're gonna split it into 3 equation, and you find 3 particular solutions, and you check the sum. All right? So xp will be xp1 plus xp2 plus xp3, in which xp1 second plus 2 xp1 prime plus 2 times xp1, and this is e to the power minus t cosinus up to t plus e to the power minus t sinus up to t. All right, it's clear. So this is case number 6 that we have just studied. So you're gonna find the particular solution by taking the sum of 3 different particular solutions. The first one will be the solution of the equation in which the force is just e to the power minus c cosinus and e to the power minus c sinus. This is case number 6. Case number 2 is the next one is the case number 2. Right, so this is case number 2. All right. The next one, you find a particular solution for the e to the power minus c. This is case number 2. The last one will be particular solution for the minus 3 cosinus t. And this is case number 4. All right? Yes?
Why do you have 2xp1 when the equation in the example is m2?
So this is x. Can you sign the back note paper, please? All right. So basically, you have to solve 3 different equations. You split it into 3 cases. The first one is this one, the second one is this one, and the third one is this one. Questions? Right. So now let us try to solve to find xp1. xp1 will be t to the k, a times e to the t minus c cosinus 2t plus b times e to the power minus c sinus 2t. Right? So to find the xp1, we use the table, and the table gives you t to the k, a e to the power minus c cosinus 2t plus b times e to the power minus c sinus 2t. Right? Right, so what is the value of k in this case? K is the multiplicity of what?
Negative 1 plus 2i.
Yes. Can you sign the back of paper, please? So k is the multiplicity of minus 1 plus 2i as the root of square plus 2r plus 2 is 0. All right? So what is k? Yes?
Isn't k 0 because the roots are -1 plus or minus I?
Yes, can you sign the back of paper, please? But this equation has 2 roots, right? So R12 will be minus 1 plus or minus I. So this is completely different from 1 plus 2i. So k is 0. xp1 will be a times e to the power minus t cosinus t plus b times e to the power minus t sinus of t. All right? Right, so we are done with the first equation. I explain again. So xp1 will be the solution of the particular solution with the first force, and here you have tk, right? The k here will be the multiplicity of minus 1, which is the term here, right? Which is the constant. Yes, this is minus 1, and this is 2. So k will be the multiplicity of minus 1 plus 2i as the root of the characteristic equation. But the characteristic equation has 2 solutions, minus 1 plus or minus 2 minus I, so k is 0. And so this is xp1. Questions? Now what is the form of the second guy? Yes?
Is it a constant times e to the negative t times t to the k?
Yes. So can you sign the back of paper, please? So xp2 will be a times t to the k e to the power minus t. So what is the k in this? So what is the k? K is the multiplicity of what? Yes?
Negative 1.
Yes. Can you sign the back of the paper, please? So k is the multiplicity of minus 1 as the root of r squared plus 2r plus 2 is 0. Right? And what is k? Yes?
0.
Yes, can you sign the back of the paper, please? So minus 1 is not a solution of this kind, right? So minus 1 squared plus 2 minus 1 plus 2 is not 0. So k is 0. So basically, ISP2 will be, I'm not going to use I because it's going to be confused with the other one when I take the sum. So it's going to be c times t to the k, c times e to the power minus c. All right? Questions? Now I have to find XP2. XP2 will satisfy this one. I use a table and I find CTK e to power minus c. K is multiplicity, minus 1 as solution of the characteristic equation. So this has to be 0. And this is the form of XP2. Now I have to find XP3. XP3 will be XP3 second plus XP3 prime plus 2 times XP3 is equal to minus 3 times cosinus of t. All right? So what is the form of XP3? Yes?
T to the k times, I guess we could call it our constant, d times cosine t plus e times sine t.
Right. Can you sign the back of the paper, please? So you're going to have d cosinus of t plus e sinus of t. Right? So what is the value for k? Yes?
K is the multiplicity of r equals I as a root of the equation, and if that's not a solution, so it's 0.
Right. Can you sign the back of the paper, please? K will be the multiplicity of I as the solution at the root of I squared plus 2r plus 2 is equal to 0. So I is not a solution, so K is 0. So SP3 will be d cosinus t plus e sinus t. All right? Questions? It's clear? Right. So now, what is the form of XP? Yes?
It's a times e to the negative t times cosine of 2t plus b times e to the negative t times sine of 2t plus c times e to the negative t plus d times cosine t plus e times sine t.
Right. So you're going to take the sum of all of three things and you get a particular solution, right? You just have to make that paper, please. So, so finally, I'm going to take the sum. So I have XP1 plus XP2 plus XP3. And this gives me I e to the power minus t cosinus 2t plus b e to the power minus t sinus 2t plus c t to e to the power minus t plus d cosinus t plus e times sinus t. Alright, so this is the form of the particular solution. You have to take the sum of all of the three particular solutions of the three sub-equations. Alright? And in exam, I'm going to ask you to write out this form. You don't have to compute the coefficients. Questions? Right, so the key here is that you have to know how to use this table, and that would be fine, because you are allowed to take the table into the exam. So the point is that you know how to use the table, right? For the case 5, 6, 7. Any questions? All right, so let us go to case number 7. Case number 7. So ft with dt e to the alpha t cosine of beta t plus qt e to the alpha t sine of beta t. So P is degree m, Q is degree n. So S will be the max of m and n, and XP will be T case A0 plus A1T, ASTS by e to the alpha t, cosinus of beta t, plus B0 plus B1t plus BSTS e to the alpha t cosinus beta t. Right. So the form becomes more and more complicated when you go to higher and higher cases. So then in this case will be the multiplicity of alpha plus beta I, right? So I explain again. In this case, you have a polynomials times an exponential times cosinus, and this is polynomial times exponential times sinus. All right? So this is very complicated, but you have the table. So in the table, you find that, okay, if P is of degree n and Q is of degree n, so you're going to consider the maximum of m and n, and XP okay, so the table is good. So there was only one mistake in the previous time. Right, so there's nothing wrong with the table. I was afraid that there was something wrong. No. So basically, so the table is good. So there was only one mistake that I showed you last time, and everything else is good. So in this case, P is of degree m, Q is of degree n. The S is the max of m and n. So XP will be t to the k times a polynomial of degree s. S is this guy, right? And you put the exponential back here, and then the cosinus back here, all right? And then you put a sinus here, and you put alpha here, and this is a polynomial of degree s, all right? And k will be the multiplicity of alpha plus beta. Questions? Right, so let us try to do one example. This is example 2.6.14. You have x second plus 3x prime plus 2x is equal to t e to the power minus t cosinus of 2t. Right, so what is the form of XP in this case? Yes?
It's t to the k times e to the negative t times cosine of 2t times a naught plus a1t.
Right. Can you say the back of the and then there's also sinus.
Yes.
So in this case, the pt, which is the coefficient of cosinus 2t, is t, and the qt will be 0. So basically, m here is 1, and n here is 0. All right? So you look into the coefficient of cosinus and sinus. The coefficient of cosinus is t. This is something of degree 1. The coefficient of sinus is 0. This is something of degree 0. So basically, the s will be 1. 1 and 0 is 1. Because s is 1, I can use this formula. So xp will be t to the k of a0 plus a1t e to the power minus t cosinus of 2t plus b0 plus b1t e to the power minus t sinus of 2t. All right? Questions? Right. So p is t, q is 0. So the degree is 1. The degree is 1, which means that the s here is 1. So I can plug this formula here, have a0 plus a1t times this one, and b0 plus b1t times this one. All right? So what is the k? What is the k? Yes?
The k is 0 because r is equal to -1 and -2.
Can you say in the magnifying paper, please? So k is the multiplicity of minus 1 plus 2i as a root of r squared plus 3r plus 2, 0. And so this is 0. All right? So k will be the multiplicity of minus 1 plus 2i. So this is minus 1 to plus 2i. Minus 1 plus 2i as the root of the characteristic equation. But this is not a solution of the characteristic equation, which means that k is 0. All right? So we continue on Thursday.